Welcome to a new lesson. In this lesson, we will be using an elimination strategy to solve a system of linear equations. Let's take a look at an example. Solve this linear system by elimination. So we are given two equations, and it is a good idea to label them as 1 and 2, so that we can identify which equation is which. We just named the equations. The next thing, notice that the x's are lined up right beneath each other, and so are the y's, and so are the constant values of 7 and 8. And the constant values are on the right-hand side of the equation. Sometimes you'll have to rearrange the equation so that the x, y's, and the the constant numbers are lined up. The next part is to eliminate one of the variables. It is your choice which variable to eliminate, either x or y. In this case, you should make a decision which one to eliminate. Usually, the rule of thumb is that, looking at the coefficients, which of the coefficients are smaller? In this case, the coefficient 5 is smaller than coefficient 6, so we're going to be eliminating for the x. So what I'm going to do is I'm going to recopy the two equations so that it is more clear of the procedure of how to eliminate this variable x. We can't just eliminate it. What we have to do is we have to match the coefficients together. So we're going to take the coefficients of the x's. The coefficients are 3 and 5. And we're going to find an LCM, or lowest common multiple, of 3 and 5. A good rule of thumb is just to multiply them, and it's usually that works. So in this case, 15 is the lowest common multiple. So what we're going to do is we have to change the 3, which is right here, to the 15. The way we do this in the equation is by multiply the entire equation by a value that makes that 3 into a 15. And that is a 5. The 5 in the second equation has to be changed to a 3. So what we're going to do is we're going to multiply the entire equation by 3. It's good practice to draw lines like so. When we multiply, each and every term has to be multiplied by this 5. So the first equation becomes 3 times 5, which is 15. Don't forget the x. Negative 4 times 5 is negative 20. Don't forget the y. And 7 times 5 is 35. We do the similar procedure in the second equation. We multiply the 3 by each and every term in the equation number 2. So 3 times 5 is 15. X. Negative 6 times 3 is negative 18, y, and 8 times 3 is 24. Notice now that the 15s have identical coefficients. This is where we need to decide to add or subtract equations from each other. So let's take a look at the signs in front of the 15s. They're all positive. If we add 15 to a 15, then we'll get 30. So what we're going to do is we are going to subtract the two equations. Why subtract? Because positive and negative 15 will add up to 0. And in fact, we're going to have a 0x. Then we're going to subtract all the other values, at least negative 20y minus negative 18y. In this case, we'll get positive or negative. It's going to be negative 2y. And 35 minus 24 is 11. Since we have 0x, we tend to not to write 0x. We just eliminate it. Then the other part is to solve for y. We have one equation and one unknown. We could solve for y. We divide both sides by -2, and therefore y becomes 11 divided by -2, which is -5.5. This is your y value. We still need to solve for the x value. We're going to use a substitution method to solve for the x value. So this is where we take the first or the second, now it's your choice, equation. So we're going to take the first equation, 3x minus 4y equals 7. And now what we're going to do is we're going to substitute the value of y, which is -5.5, and solve for x. So 3x minus 4 times -5.5 is equivalent to 7. I'm going to solve now for x. 3x, -4 times -5.5 is -21, pardon me, 22, and it's positive because negative times negative is 22, is equal to 7. Then we're going to subtract -22 from both sides of the equation because we need to isolate for x. So on the left-hand side we have 3x. The 20 minus 22, so 22 minus 22 is 0, so that cancels out. And 7 minus 22 is -15. We then keep going by dividing by 3 on both sides. And x, therefore, will equal to -5. And that's what your x value will equal. So we solved the equation. However, for each system of equations, the solution has to be verified. So we need to verify that indeed this is the answer. And we need to verify it twice. That means we have to solve it, or actually we have to plug it into the first two equations to see that indeed this is the case. So we erased the first, all the procedure to solve for this equation. Now we're going to verify. So the first equation, which is going to be recopied. Make sure you copy the question correctly. One of the first mistakes you can make is by copying the question incorrectly. We're going to plug in these values for x, which is -5, and values for y, which is -5.5. We're going to see that we're going to get, if we can get 7. If we do get 7 in your calculator, then at least for this question, not for this question, but for this first equation, the solutions work. So we'll have 15, -15, 3 times -5 is -15, plus 22, and that does equal to 7. So it is verified for the first equation. For the second equation, we again plug these values of x, -5, and y of -5.5 to see if we get 8. So we know that 5 times -5 is -25, and -6 times -5.5 is +33. And if you add them up, you get 8. Oh, so that means it also works. Therefore, x equals -5 and y equals to -5.5 is a verified solution to our equation. Let's try a little bit more complicated question. Use an elimination strategy to solve this linear system. Now, fractions pose a lot of problems to a lot of students. 3 and 2, for example. What we are going to do before we use elimination method is change this equation. That means change equation number 1 and change equation number 2 so that we do not have fractions anymore. Recognize the first equation, 3 and 2, and find its LCM. lowest common multiple. In this case, it's 3 times 2, which is 6. That's its lowest common multiple. So let's rewrite it. And then we're going to multiply each and every term by its lowest common multiple. By 6 in this case. Now this is the tricky part. So in this case, when we multiplied, it's the same thing as dividing, really. We could multiply and then divide. The order of operation does not matter. So 6 divided by 3 is 2. 6 divided by 2 is 3. So in this case, we could get rid of these fractions, and the fractions now are gone. And now we do the multiplication. 2 times 2 is 4. Don't forget the x. Negative 1 times 3 is negative 3. Don't forget the y. And 4 times 6 is 24. This is our number 1 equation transformed. Now we have no fractions. We're going to use the similar process for the second equation. Recognize that 2 and 4 are the fractions. So what is the lowest common multiple of 2 and 4? In this case, we don't multiply 2 and 4 to get 8. Right away we know that 4 is a multiple of 2. Since 4 is a multiple of 2, really 4 is the LCM of this operation. So after we rewrite the equation, second equation, we're going to multiply each and every term by the lowest common multiple, which is 4. And again, we're going to use simplification or division. We know that 4 divided by 2 is 2. We know 4 divided by 4 is 1. And 4 divided by 2 is 2. Then instead of division now, or instead of having fractions, we're going to multiply the numerators together. 1 times 2 is 2. Don't forget the x. 1 times 1 is 1. Don't forget the y. And 5 times 2 is 10. And this is our second equation. Now what we're going to do is we're going to take these two equations and solve them. Meaning we're going to use the elimination method to solve for our x and y values. So I'm going to erase everything and set this up nicely. Now we're going to solve for it. The first thing we need to decide is what variable we're going to cancel. In this case, it's easier to cancel for the y is because the coefficient of 1 is just 1. And in order to match the coefficients, we would have to multiply the second equation only by 3. So we're going to multiply the 3 with every term in the second equation. It's good practice to rewrite the first equation always and never change the order. So the second equation is going to be 3 times 2, which is 6x. 3 times 1, which is positive 3. Don't forget the y. And 3 times 10 is 30. It's often a common mistake to forget to multiply the constant term, which is 10 by 3. We're going to continue on and recognize that now we have the 3's that are identical. Now you have to decide whether you're going to add the equations together or subtract them. Since the operations or the signs and the variables that we're going to be eliminating are different, we are simply going to be adding. Why? Because negative 3 plus positive 3 is 0, and y will be eliminated. So we're going to add. We know that we're going to get 0 y's, and 4 plus 6 is 10 x's. On the right hand side, we're going to have 24 plus 30, which is 54. Then we're going to divide both sides by 10. And therefore x, because x 10's will cancel, will be 54 over 10, or 5.4. And this is the first variable in your solution. The next part is to solve for y. What we're going to do is we're going to take this value of x and plug it into one of these equations, or the original ones, to see if, in fact, actually not to see, but actually to find the answer for y. So let's plug that in. Let's recopy the first equation. And now we're going to plug in the value of x. So here you go. X is actually 5.4. Then we're going to multiply it by 2 and divide by 3. And that's 3.6. And we're going to recopy everything else. Now we're going to subtract 3.6 from both sides of the equation. We're going to isolate for y and solve for y. So on the left-hand side we have 1/2 y. And on the right-hand side we have 4 minus 3.6, which is 0.4. The last part is that we're going to multiply both sides by -2. And when we do this, we're going to be canceling out the fraction. So that on the left-hand side, we're just going to have y. And on the right-hand side, we'll have 0.4 times -2, which is 0.8. And of course, don't forget the negative. So this is our y value for the solution. So this is just the solution of the equation. We still need to verify that indeed x is 5.4 and y is -0.8. And we verify is by plugging both these values back into the two equations provided. So let's get rid of some algebra and recopy the equations. The first equation and the second equation. Now we're going to plug in these x and y values into our equations and see if we get 4 and 5/2. So in the first equation, we'll plug it in. So 2 times 5.4 divided by 3, subtract 1/2 times -0.8, and we'll get the value of 4. This means that we are verifying that it works for our first equation. The solution works for our first equation. Then we'll do the same thing for the second equation. We plugged it in 5.4 for x and -0.8 for y. If you plug this in your calculator, you'll find out that the value is 5/2 or 2.5. So it does equal to 5/2. Therefore, we have verified that this solution works for both of these equations. Therefore, it is correct.